Okay, 23, 24, 25, and 26 are all confidence intervals. 23 says, in a random sample of 60 computers, we're constructing a confidence interval. N is greater than or equal to 30, which means we have a large sample, and we're going to use the interval in the calculator. Remember, to get there, we're going to hit Stat and scroll over to Tests. Be very careful that we don't choose the test, that we choose the interval. Option 7 here. In your calculator, we have the statistics, so we want to highlight the statistics. If for some reason you get some kind of funky symbols here, or you start entering in information and you get kicked out, okay, so after you enter in the standard deviation of 36, it kicks you out, says error or whatever. Go into Stat, go to Calculate, select the one variable statistics, and make sure you get some statistics here. If you don't, make sure you have some numbers in a list, then hit Stat, Calculate one variable statistics. Now when you go into that test, you will be able to perform the confidence interval. So our standard deviation is 36, our mean repair cost is $150, and our sample size was 60, and then our C level of confidence was 99. You hit Calculate, here's our interval. Now on the final exam, this might say something like 138 to 162. It might not give all 5 significant digits that the calculator gives you for the confidence intervals. Okay, 24. In a recent study of 82 8th graders, the mean number of hours per week that they watched television was 19.6 with a standard deviation of 15.8. Find the 98% confidence interval. Well, N is 42, so again, N is greater than or equal to 30, so it is a large sample. So we're using Z interval. So I'm going right back into the test in the calculator, selecting option 7. Again, we have the statistics, not the list of the data. Our standard deviation is 5.8. Our mean is 19.6. N is 42. Our confidence level is 98. So here's our confidence interval. 25. Construct a 90% confidence interval. Assume the population is randomly distributed for a random sample of 20. So N equals 20, so N is less than 30, which means we have a small sample. Let's see, our mean was 3,200. Our standard deviation is $665. So we go to Stat, Test. This time we want T interval. We still have statistics. We don't have a data set. Oops. Our mean is 3,200. Excuse me. Our standard deviation is 665. And our sample size is 20. Our confidence level is 90. Again, I'm just pulling these numbers directly from the problem. Now I hit Calculate. And my interval is from $2,942.9 to $3,457.1. 26. Construct a 95% confidence interval for the population mean. We have a random sample of 16, so N is 16. We're calculating our confidence interval for a mean of a small sample. So we're going to use T interval. So Stat, Test, it should be option 8. We have the statistics. Our mean here is 645 hours. Our standard deviation is 31 hours. And our sample size was 16. We want a 95% confidence interval. We calculate, and we get 628.48 hours to 661.52 hours. 27. When 415 college students surveyed, 175 said they own their car. Construct a 95% confidence interval for the proportion of college students who say they own their cars. So this one, remember, we want one proportion Z interval. So I'm going to go to stat test. This one we're going to have to scroll down for. Be careful not to select the one proportion Z test. Here's option A. So my X, the number of students that said they owned their car, was 175 out of a total of 415 that were surveyed. And it's a 95% confidence interval, and we calculate. We get 0.37418 to just about 47%. Now we're getting into hypothesis testing, our last unit here. It says that our null hypothesis is that our mean equals 25, and our alternative hypothesis is that the mean does not equal 25. Determine whether or not the test is left tail, right tail, or two tail. We determine our type of a test from the alternative hypothesis. If our symbol is less than, it's a left tail test. If our symbol is greater than, it's a right tail test. If it does not equal, it's a two-tailed test. Given that our null hypothesis, our probability of success is less than or equal to 0.25, determine whether the hypothesis test is left tail, right tail, or two tail. Well, we need our alternative hypothesis, which is the complement to less than or equal to, which is greater than. And when we have a greater than in our alternative hypothesis, the symbol points to the right. We have a right-tailed test.